Hello, in this lecture we'll find out the length of line segment X. In the drawing we have two quarter circles. The two quarter circles touch each other at point B. We also know that line segment AB equals to 1 unit in its length, and line segment QS equals to line segment SP. And our mission is to find out the length of this line segment BC that is equal to X. Okay, so first of all we know that PAB is a quarter circle, therefore PA equals to AB. They are both the radii of this quarter circle, and because of the fact that AB equals to 1, then PA must be also equal to 1. In the next step, we join points P and B together by a straight line. By joining points P and B, we create the right triangle PAB. So we copy the right triangle PAB in a new page, and we will implement the Pythagoras theorem on this right triangle PAB. Here by PT is the variation for Pythagoras theorem. So actually, this is the right triangle PAB that I copied from the original drawing. According to the Pythagoras theorem, it is right triangle PAB, PB square equals to PA square plus AB square. So PB square, that is the square of the hypotenuse, equals to PA square. PA is 1, therefore PA square is 1 square, that is 1, plus AB square. AB is 1, therefore AB square is 1 square, that is 1. So in total PB square equals to 1 plus 1, that is 2. PB square equals to 2. We take out of this equation, and finally we get that PB equals to the square root of 2 units. So here, the hypotenuse PB equals to the square root of 2 units in its length. We continue to focus on the right triangle PAB. Here, side PA equals to side AB. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if we define this angle is alpha, then the other angle must be also equal to alpha. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in the right triangle PAB. So the sum of the angles in the right triangle PAB must be equal to 180 degrees. So each angle we have this angle that is equal to 90 degrees plus alpha plus alpha, that is 2 alpha. In total, they must be equal to 180 degrees. So 90 degrees plus 2 alpha equals to 180 degrees. we subtract 90 degrees from this equation, and finally we get that 2 alpha equals to 180 degrees minus 90 degrees, it is 90 degrees. So 2 alpha equals to 90 degrees, we divide this equation by 2, and finally we get that alpha equals to 90 degrees over 2 is 45 degrees. So we actually found out that this angle alpha equals to 45 degrees. And this is also angle alpha that equals to 45 degrees. In the next step, we join points Q and B together by a straight line. By joining points Q and B, we created the right triangle, triangle QCB. We know that in the quarter circle QCB, BC equals to QC. They are above the radii of this quarter circle. So, but BC is x, therefore QC must be also equal to x. So, we already found out that in the right triangle PAB, that PA equals to AB, then those two angles are both equal to 45 degrees. Therefore, according to the same reason, those two, in the right triangle PQB, those two sides are equal to each other. Therefore, those two angles, each of them must be equal to 45 degrees in their sizes. So, we will continue to focus on the right triangle, triangle QCB. So, we copy the right triangle, triangle QCB in the new page, and we will implement the Pythagoras theorem on this right triangle, triangle QCB. So this is the right triangle QCB, that is the curvature of the original drawing. Here by PT is the evolution from Pythagoras theorem. In the right triangle QCB, according to the Pythagoras theorem, QB square equals to QC square plus BC square. So QB square equals to QC square. QC is x, therefore QC square is x square plus BC square. BC is x, therefore BC square is x square. So in total QB square equals to x square plus x square, that is 2x square. QB square equals to 2x square. We take a root out of this equation, and finally we get that QB equals to the square root of 2 times x square. The square root of x square is x, so inside the root we left only with 2. So in total we found out that QB equals to square root of 2 times x. The left of the hypotenuse QB is square root of 2 times x. So we can write here that QB equals to the square root of 2 times x, units in its length. Okay, in the next step I will present to you a new rule, and we will implement rule number 3 actually in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So here in the drawing we have the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha plus this angle that is beta. So alpha plus beta in total must be equal to 180 degrees according to this rule, rule number 3. So we can actually implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the upper side of the straight line AC, if we focus on the upper side of the straight line AC at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So I'll copy the straight line AB with point B in a new page and we'll implement rule number 3 in this straight line AC. So actually, this is the straight line AC that I copied from the original drawing. According to rule number 3, the sum of the angles on the upper side of the straight line AC at point B must be equal to 180 degrees. So which angles we have at the upper side of AC at point B? We have this angle that is equal to 45 degrees, plus the missing angle that we will define as X. In total, plus this angle is equal to 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So 45 degrees plus 45 degrees is 90 degrees, plus x equals to 180 degrees. We subtract 90 degrees from the equation, finally we get that x equals to 180 degrees minus 90 degrees, that is 90 degrees. So the missing angle here must be equal to 90 degrees in its size. So we can write down the original drawing. The missing angle here must be equal to 90 degrees in its size. We know that any triangle can be blocked by a circle. Therefore, I'll copy the right triangle PBQ in a new page and we will block this right triangle, triangle PBQ. Actually, this is the right triangle BBQ that is blocked by a circle. Side BB equals to the square root of 2 units in its length. Side BQ equals to square root of 2 times x units in its length. So here, in the drawing itself, we have a circle. Inside this circle, we have peripheral angle PBQ that's equal to 90 degrees in size. So here we have rule number 5 that we can implement on this drawing. According to rule number 5, any peripheral angle that's equal to 90 degrees must rest on the diameter of the circle. So we have in the drawing a circle. Inside this circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in size. Therefore, according to this rule number 5, peripheral angle MAN must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MAN rests on chord MN, and indeed chord MN is the diameter of the circle. Why? Because chord MN passes from point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. So, because of the fact that, in conclusion, peripheral angle MAN equals to 90 degrees in size, therefore it rests on chord MN, that is the diameter of the circle. So we can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle QBP. This peripheral angle QBP equals to 90 degrees in its size. Therefore, according to rule number 5, peripheral angle QBP must rest on the diameter of the circle. So, from the drawing itself, it is very easy to see that peripheral angle QBP rests on chord QP. Therefore, according to rule number 5, and I write it down, peripheral angle QBP equals to 90 degrees in its side. Therefore, according to rule number 5, peripheral angle QBP must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle QBP rests on chord QP. Therefore, according to rule number 5, chord QP is the diameter of the circle. QP is the diameter of the circle. So, if we define the radius of this circle as R, if the radius is R, then the diameter QP must be equal to 2R. QP equals to 2R. From one side QP equals to 2R, but from the other side it is given us the equation that PS equals to SQ, PS equals to QS, PS equals to QS. So if PS is X, then QS must be also equal to X. So in total, PQ equals to PS, that is X, plus SQ, that is X. So in total, PQ equals to X plus X, that is 2X. So from the other side, PQ equals to 2X. From the other side, PQ equals to 2X. So from one side, QP equals to 2R, from the other side, QP equals to 2X. So from these two equations, we will derive that 2R equals to 2X. Okay? From those two equations, we derive that 2R equals to 2X. Here we divide this equation by 2, and finally we get that R equals 2X. Okay, so here So PS, that is X, it is equals to R, and SQ, that is also X, it is equals to R. So QS equals to R, and PS equals to R. So those two radii touch each other at point S. Therefore, point S must be the center of the circle. Repeat again. PS is the radius of the circle, and QS is also the radius of the circle. So those two radii touch each other at point S. Therefore, point S is the center of the circle. So I write it down. Point S is the center of the circle. In the next step, we join points S and B together by a straight line. So point S is the center of the circle, point B is the point of the circle itself, therefore SB is the radius of the circle that is equal to R. So in conclusion, we found out that PS equals to SB equals to SQ, all the three line segments are the radii of this circle that is equal to R. So here we join points S and B together by a straight line. We found out that SB is the radius of the circle that is equal to R. And again, PS equals to SB equals to SQ, all the radii of this circle that is equal to R. And especially SB equals to SQ, they are both the radii of this circle that is equal to R. Okay. In the next step, we'll complete the quarter circle, the big quarter circle to a circle. Again, we'll complete this quarter circle to a circle. So completed the quarter circle to a circle. We join points Q and B together by a straight line. In the next step, I present to you rule number 13 and we will implement rule number 13 in our drawing. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB equals to theta in its size. And peripheral angle ACB is subtended on arc AB. Again, peripheral angle ACB is subtended on arc AB. And we also have here central angle AOB. This central angle AOB is also subtended on the same arc, arc AB. Therefore, according to rule number 13, if a central angle and a peripheral angle, they are both subtended on the same arc, the central angle is always will be twice as large as the peripheral angle. And because of the fact that the peripheral angle ACB equals to theta, then the central angle AOB that is subtended on the same arc, arc AB, must be equal to 2 theta. Again, the central angle is always twice as large as the peripheral angle that is subtended on the same arc. In this drawing, we have peripheral angle ACB that is equal to theta, and it is subtended on arc AB. And therefore, peripheral angle AOB that is subtended on the same arc AB must be equal to 2 theta. So we can actually implement rule number 13 in our drawing. Why? Because in our drawing we have peripheral angle BSQ. This peripheral angle BSQ is subtended on arc BQ. Again, peripheral angle BSQ is subtended on arc BQ. Therefore, this central angle BCQ, central angle BCQ is subtended on the same arc RBQ. Therefore, this angle, the central angle BCQ, must be twice as large as the peripheral angle BSQ that is subtended on the same arc, arc BQ. What is the size of this central angle BCQ? We use here rule number 6. According to rule number 6, the sum of the angles around the point always add up to 360 degrees. So in the drawing we have here point A. According to this rule number 6, the sum of the angles around point A must be equal to 360 degrees. We prove this rule number 6, actually by drawing a straight line from point A. This straight line passes from point A. And here we have rule number 3 that states that according to rule number 3, the sum of the angles on the upper side of the straight line, the sum of the angles on the upper side of the straight line at point A must be equal to 180 degrees. So which angles we have at the upper side of the straight line at point A? We have this angle must be equal to 180 degrees according to rule number 3. Likewise, according to the same rule number 3, the sum of the angles on the lower side of this straight line at point A must be also equal to 180 degrees. So this angle must be equal to 180 degrees. So in total, the sum of the angles around point A is 180 degrees plus 180 degrees, that is 360 degrees, exactly according to this rule number 6. We can actually implement rule number 6 in our drawing. Why? Because in our drawing, we will focus on at point C. Here at point C, according to rule number 6, the sum of the angles around point C must be equal to 360 degrees according to rule number 6. So which angles we have around point C? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 360 degrees according to rule number 6. So, because of the fact that this angle equals to 90 degrees, the missing angle must be equal to 270 degrees. Why? Because 270 degrees plus 90 degrees, this 360 degrees, exactly according to rule number 6. So, the missing angle here, this angle must be equal to 270 degrees in its size. Okay? So, actually, the central angle BCQ that is subtended on arc BQ must be twice as large as the peripheral angle BSQ that is also subtended on the same arc BQ. And because of the fact that the central angle BCQ is equal to 270 degrees in its size, therefore the peripheral angle BSQ must be equal to half of it. That is to say, it must be equal to 270 degrees over 2, that is 135 degrees. Okay. So peripheral angle BSQ equals to 135 degrees and the central angle BCQ equals to 270 degrees. Okay, so we know that BS equals to SQ. So in triangle BSQ, BS equals to SQ. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And we also know that the sum of the angles in any triangle, and especially in triangle BSQ, must be equal to 180 degrees. So which angles we have inside triangle BSQ? We have in triangle BSQ, we have this angle that is equal to 135 degrees plus alpha that is plus 2 alpha. In total, they must be equal to 180 degrees. So here we subtract 135 degrees from this equation and we get that 2 alpha equals to 180 degrees minus 135 degrees is 45. So 2 alpha equals to 45. We divide this equation by 2 and finally we get that alpha equals to 45 over 2 degrees. Okay, so this again equals to 45 over 2 degrees and this again alpha also equals to 45 over 2 degrees. So I can write down here that this is actually angle SQB, that is alpha, that is equals to 45 over 2 degrees. So I'll copy the right triangle PBQ in a new page and we'll analyze this triangle PBQ. Again, this angle PQB equals to 45 over 2 degrees. So actually, this is the right angle PBQ that I copied from the original drawing. Side PB equals to the square root of 2 units, and side QB equals to the square root of 2 times x units in its length. And this angle equals to 45 over 2 degrees. So in this right angle, triangle PBQ, tangents 45 over 2 degrees equals to PB over BQ. Again, tangents 45 over 2 degrees equals to PB over BQ. PB is square root of 2 over BQ is square root of 2 times x. So we have 2 in the numerator, we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. And we're left only with 1 over x. So in conclusion, found out the tangents 45 degrees over 2, this is according to equation number 1, tangents 45 degrees over 2 equals to 1 over x. This is according to equation number 1. And we also have the trigonometric identity, the tangents to theta equals to 2 tangents theta over 1 minus tangents square theta. Okay. We will define theta as 45 degrees over 2. Theta equals to 45 over 2. So if theta equals to 45 over 2, it means that 2 theta equals to 45 degrees. Now we will substitute theta and 2 theta in this trigonometric identity by 45 degrees over 2 and 45 degrees. And we get that according to equation number 2, tangents and 2 theta is 45 degrees is equals to 2 times tangents and theta. Theta is 45 over 2 over 1 minus tangents square theta. And theta is 45 over 2. Here we will define tangents 45 over 2 as t. Repeat again. According to our definition, tangents 45 over 2 equals to t. Now we can substitute tangents 45 over 2 in this equation number 2, by t. We'll do it now, and we'll get that according to this equation number 2, tangents 45 degrees is 1, and it is equals to 2 times tangents 45 degrees over 2, and tangents 45 degrees over 2 is t, according to our definition. So we substitute tangents 45 over 2 by t. So this expression, in the numerator, we will have in total 2t over 1 minus tangents square 45, tangents 45 over 2 squared. So if tangents 45 over 2 is t, then tangents squared 45 over 2 will be equal to t squared. So in total, in the denominator, we'll have 1 minus t squared. So actually we found out that according to equation number 2, 1 equals to 2t over 1 minus t squared. Here we will multiply this equation by 1 minus t squared, and we'll get that according to this equation number 2, 1 minus t squared equals to 2t. Here we relate to this equation number 2t squared, and we get that according to this equation number 2, 1 equals to t squared plus 2t. Here we subtract 1 from this equation number 2, and finally we get that t squared plus 2t minus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 1. So we'll put the data inside the equation for x, and we'll find out the value or the values of t, because x equals to t. And we get that, so x equals to t, so t equals to minus b. b is 2, therefore minus b is minus 2, plus minus square root of b squared. b is 2, so b squared is 2 squared, that is 4, minus 4 times a is 1, times c is minus 1. All divided by 2a, so 2 times a is 1. So in conclusion, we found out actually that t equals to minus 2 plus minus, inside the root we have 4, and minus 4 times minus 1 is plus 4. So it is 4 plus 4, that is 8. Inside the root we have 8 over 2. So in conclusion, we found out actually that t equals to minus 2 plus minus square root of 8 over 2. So t equals to minus 2 plus minus square root of 8. 8 is 4 times 2, so we substitute 8 by 4 times 2 over 2. So t equals to minus 2 plus minus, the square root of 2 is 2, so inside the root we left only with 2. So it is t equals to minus 2 plus minus 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1. So we left only with square root of 2. So in conclusion, found out that t equals to minus 1 plus minus square root of 2. So here we have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. And the second solution for t is that t equals to minus 1 plus square root of 2. According to our definition, t equals to tangent 45 over 2 degrees. But tangent 45 over 2 degrees is a positive number, so t is a positive number. So t that is a positive number, it is equals to t that is a positive number, it is equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number. A positive number can never be equal to a negative number. T that is a positive number can never be equal to a negative number. So this solution is an incorrect solution, and we cancel this solution, and we're left only with the second solution that is possible for t, that t equals to minus 2 plus square root of 2. Again, t equals to tangents 45 over 2 degrees. So tangents 45 over 2 equals to minus 1 plus square root of 2. This is according to equation number 2. While according to equation number 1, we have already found out that tangents 45 over 2 degrees equals to 1 over x. This is according to equation number 1. Again, according to equation number 2, we found out that tangents 45 degrees over 2 equals to minus 1 plus square root of 2. While according to equation number 1, we already found out that tangents 45 over 2 degrees equals to 1 over x. In the next step, we create equation number 3. It states that we have two expressions for tangents 45 over 2 degrees. Therefore, we create equation number 3 that states that tangents 45 over 2 degrees according to equation number 1, that is 1 over x, must be equal to tangents 45 over 2 degrees according to equation number 2, that is square root of 2 minus 1. Repeat again. Equation number 3 states that tangents 45 over 2 degrees according to equation number 1, that is 1 over x, must be equal to tangents 45 over 2 degrees according to equation number 2, that is square root of 2 minus 1. So here we'll multiply this equation number 3 by x, and finally we get that according to equation number 3, 1 equals to x times square root of 2 minus 1. Here we divide this equation number 3 by square root of 2 minus 1. And finally we get that x equals to 1 over square root of 2 minus 1. Okay, x equals to 1 over square root of 2 minus 1. So x equals to 1 over square root of 2 minus 1. Here we will focus on this side of the equation, and we will multiply this side of the equation by square root of 2 plus 1, and then we will divide it by square root of 2 plus 1, so we change nothing. It is allowable. We will multiply this side of the equation by square root of 2 plus 1, and then we will divide it by square root of 2 plus 1. Actually, we multiply it by 1, so it is allowable. And we'll get that x equals to square root of 2 plus 1, and we have here square root of 2 minus 1 times square root of 2 plus 1. This expression, according to the algebraic identity, that a minus b times a plus b equals to a squared minus b squared, according to this algebraic identity, we get that square root of 2 minus 1 times square root of 2 plus 1 equals to the square root of 2 squared, that is 2, minus 1 squared, that is 1. So in total, x equals to the square root of 2 plus 1 over 2 minus 1 is 1. So it is square root of 2 plus 1. X equals to the square root of 2 plus 1. Or in terms of numbers, the value of x is 2.414 units. And that is the answer to the question. I repeat again. The length of line segment BC is equal to x is equals to either square root of 2 plus 1 units, or in terms of numbers, BC that is equal to X, it is equals to 2.414 units. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment BC that is equal to X. So in the drawing, we have two quarter circles. The two quarter circles start each other at point B. In addition, we know that AB equals to 1 unit in its length. And we also know that PS equals to QS. And BC equals to X. So our mission is to find out the length of line segment BC that is equal to X. So here we focused on the small quarter circle PAB. In this quarter circle PAB, PA must be equal to AB. Why? Because both those two line segments are the radii of this quarter circle. So PA equals to AB equals to 1, therefore PA must be also equal to 1. Then we join points P and B together by a straight line. So I copied the right triangle PAB in a new page, and we implemented the Pythagoras theorem on this right triangle PAB. This is the right triangle PAB that I copied from the original drawing. This right triangle PAB, according to the Pythagoras theorem, PB square equals to PA square plus AB square. So PB square, that is the square of the hypotenuse, equals to PA square. PA is 1, therefore PA square is 1 square, that is 1, plus AB square. AB is also 1, therefore AB square is 1 square, that is 1. So in total, PB square equals to 1 plus 1, that is 2. So PB square equals to 2. We took out of this equation and finally found out that PB equals to the square root of 2. The hypotenuse PB equals to the square root of 2 units in its length. So we can write here that PB equals to the square root of 2 units in its length. Then we continue to focus on the right triangle PAB. On the right triangle PAB, PA equals to AB. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. Okay, and we know that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have inside the right triangle PAB? We have alpha and 90 degrees. So in the right triangle PAB, the sum of the angles must be equal to 180 degrees. So the angles that we have in the right triangle PAB are 90 degrees plus alpha, this is 2 alpha. So 90 degrees plus 2 alpha must be equal to 180 degrees. Here we subtract the 90 degrees from this equation and finally found out that 2 alpha equals to 180 degrees minus 90 degrees, that is 90 degrees. Here we divide this equation by 2 and finally found out that alpha equals to 90 degrees over 2, that is 45 degrees. So this is angle alpha that is equal to 45 degrees in size, and this is also angle alpha that is equal to 45 degrees in its size. And in the big quarter circle QCB, QC equals to CB, they're both the radii of this quarter circle, therefore they're equal to each other. So BC is X, therefore QC must be also equal to X. Then I copied the right, we joined points Q and B together by a straight line. In this way we created the right triangle QBC. So I copied the right triangle QBC in the new page and we implemented the Pythagoras theorem in this right triangle QBC. But before that, QCB is a right triangle that is also an isosceles triangle. Why? Because QC equals to BC. And therefore, according to what we did here, those two angles must be also equal, each other must be equal to 45 degrees. So then I copied the right triangle QCB in a new page and we implemented the Pythagoras theorem in this right triangle, triangle QCB. This is the triangle QCB. This I copied from the original drawing. In this right triangle QCB, by PT's evolution for Pythagoras theorem, QB square equals to QC square plus BC square. So QB square equals to QC square plus QB square. So QB square equals to QC square. QC is x, therefore QC square is x square, plus BC square. BC is x, therefore BC square is x. So in total, QB square, that is the square of the hypotenuse, equals to x square plus x square, that is 2x square. Again, QB square equals to 2x square. We took a root out of this equation, and finally found out that QB equals to the square root of 2 times the square root of x squared. The square root of x squared is x, so in total QB equals to the square root of 2 times x. So here we have the hypotenuse QB equals to the square root of 2 times x. Okay. Then I copied, then we have rule number 3. I presented to you rule number 3 and we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha plus and this angle that is beta. So alpha plus beta in total must be equal to 180 degrees according to this rule number 3. So we can actually implement rule number 3 in our drawing. Why? Because if we focus on the upper side of the straight line AC at point B, here the sum of the angles must be equal to 180 degrees. So I copied the straight line AB at point B in the new page and implemented rule number 3 in this straight line AC. This is the straight line AC that I copied from the original drawing, and this is point B. So if we focus on the upper side of the straight line AB at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of AC at point B? We have this angle that is 45 degrees, plus the missing angle that we defined as x, plus this angle that is 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So 45 degrees plus 45 degrees is 90 degrees. So in this side of the equation, in total we have 90 degrees plus x, that is equals to 180 degrees. We subtract 90 degrees from this equation and finally found out that x equals to 180 degrees minus 90 degrees, that is 90 degrees. So the missing angle here equals to 90 degrees. So we can write here that the missing angle PBQ, this angle equals to 90 degrees in its size. Then I copied the right angle PBQ in a new page and we blocked this right angle PBQ by a circle. This is the right angle PBQ that I copied from the original drawing. And then I blocked this right angle PBQ by a circle. We know that any triangle can be blocked by a circle, and especially triangle PBQ. We already found out that PB equals to the square root of 2 and QB equals to the square root of 2 times x. This angle equals to 90 degrees. So in the drawing we have a circle. Inside the circle we have peripheral angle PBQ. This peripheral angle PBQ equals to 90 degrees in size, and we have rule number 5 that relates to peripheral angle is equal to 90 degrees in size. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So we have here a circle. Inside the circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees. Therefore, according to this rule number 5, peripheral angle MAN must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MAN rests on chord MN, and indeed chord MN, it is the diameter of the circle. Why? Because chord MN passes for point O, that is the center of the circle, and we know that any chord that passes for the center of the circle must be the diameter of the circle. So in conclusion, we can say that because of the fact that peripheral angle MN equals to 90 degrees in size, it rests on the diameter of the circle, it is actually MN. Can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle QBP is equal to 90 degrees, therefore here peripheral angle QBP equals to 90 degrees in size, therefore peripheral angle QBP, according to rule number 5, must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle QBP rests on chord PQ, therefore chord PQ must be the diameter of the circle. Here chord QP or PQ or QP, it is the same, it is the diameter of the circle, according to rule number 5. So if we define the radius of the circle as R, then the diameter QP must be equal to 2R. Okay, so according to rule number 5, the diameter QP equals to 2R from one side. But from the other side, we know that PS equals to SQ. So if PS is X, then SQ must be also equal to X because they are equal to each other. So in total, PQ equals to X plus X, that is 2X. So from one side, QP is the diameter of the circle, that is 2R. From the other side, QP equals to 2X according to what is given as the question. So from those two equations, we will derive that 2R equals to 2X. Because QP equals to 2R and QP also equals to 2X. Therefore, QP, 2R equals to 2X. Okay? Yeah, so 2R equals to 2X. So R equals to 2X. We divided this equation by 2 and finally found out that X equals to R. So here, PS, that is X, equals to R, and SQ, that is also X, equals to R. So QS equals to R, and PS also equals to R. So it is very easy to see that those two radii of the circle touch each other at point S. And therefore point S is the center of the circle. Okay, point S is the center of the circle. Point S is the center of the circle. And then we join point S and B together by certain. Point S is the center of the circle, point B is a point of the circle itself, therefore SB is the radius of the circle, that is R. So in conclusion, you can say that PS equals to SQ equals to SB. All the three line segments are the radii of this circle that equals to R. Okay, so here SB is the radius of the circle that is equal to R, and SQ also equals to R, SQ equals to R, and SB also equals to R. All the three line segments are equal to each other. They are all the radii of the previous circle. Then we did a construction. We actually completed the big quarter circle, this big quarter circle to a circle. This is the big quarter circle. We completed the big quarter circle to a circle. I repeat again that we already found out that QS equals to SB. Repeat again. QS equals to SB. QS equals to R, SB also equals to R, so they are equal to each other. So here, QS equals to R, SB equals to R. Those two sides are equal to each other. And then we join points B and Q together by straight line. and this is actually angle QCB is equal to 90 degrees. This is angle QCB is equal to 90 degrees. Then I presented to you rule number 13, and we created rule number 13 in our drawing. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB equals to theta in its size, and it rests, it is actually subtended on arc AB. And we have also the central angle AOB that is subtended on the same arc, arc AB, must be twice as large as this peripheral angle. So because of the fact that the peripheral angle ACB equals to theta, then the central angle AOB that rests on the same chord AB must be equal to 2 theta. So we can actually implement rule number 13 in our drawing. Why? Because in our drawing we have the peripheral angle BSQ. This peripheral angle BSQ is subtended on arc BQ. Again, peripheral angle QSB is subtended on arc QB. Or peripheral angle QSB is subtended on arc BQ. The big arc, big BQ. Arc BQ. And we have the central angle, that is angle QCB. This central angle QCB is subtended on the same arc, arc BQ. Therefore, according to rule number 13, the central angle must be twice as large as the peripheral angle QSB, because they're both subtended on the same arc, arc BQ. Okay, so this angle must be twice as large as this angle, according to rule number 13. What is the size of this angle? We will find the size of this angle according to rule number 6. According to rule number 6, the sum of the angles around a point will always add up to 360 degrees. So in the drawing we have point A, and according to this rule, rule number 6, the sum of the angles around point A must be equal to 360 degrees in total. So in order to prove that rule number 6 is true, we draw a straight line that passes from point A. And we have rule number 3 that states that the sum of the angles on the upper side of the straight line at point A must be equal to 180 degrees. Here. The sum of those two angles on the upper side of this straight line at point A must be equal to 180 degrees. From one side, but from the other side, according to the same rule, rule number 3, the sum of the angles in the lower side of this straight line at point A must be also equal to 180 degrees. So in total, the sum of the angles around point A must be equal to 180 degrees plus 180 degrees, that is 360 degrees. That is 360 degrees, exactly according to this rule, rule number 6. Okay, so we can implement rule number 6 in our drawing. Why? Because in our drawing, we have, if we focus at point C, according to rule number 6, the sum of the angles around point C must be equal in total to 360 degrees. So which angles we have around point C? We have this angle that is equal to 90 degrees, plus the missing angle, in total they must be equal to 360 degrees according to rule number 6. Therefore, the missing angle must be equal to 270 degrees. Why? Because 270 degrees plus 90 degrees is 360 degrees. This is the sum of the angles around point C according to rule number 6. Therefore, the missing angle here equals to 270 degrees. And because of the fact that the central angle QCB that is subtended on arc BQ is equal to 270 degrees in its size, therefore the peripheral angle BSQ that is subtended on the same arc, arc BQ, must be equal to half of it. That is to say, it must be equal to 270 degrees over 2, that is 135 degrees. So the peripheral angle BSQ that is subtended on arc BQ is equal to 135 degrees, and is half of the center angle BCQ that is also subtended on the same arc RBQ that is equals to 270 degrees. Okay. So here we have already mentioned that SQ equals to SB. They are both the radii of the previous circle, therefore they are equal to each other. Then we join points Q and B together by side line. In this way we created here triangle QSB. In the right triangle QSB, QS equals to SB. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And the sum of the angles in triangle QSB must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have inside triangle QSB? We have this angle that is 135 degrees plus alpha, that is 2 alpha. In total they must be equal to 180 degrees. So 135 degrees plus 2 alpha equals to 180 degrees. We subtracted 135 degrees from this equation and finally found out that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees, so 2 alpha equals to 45 degrees. We divided this equation by 2 and finally found out that alpha equals to 45 over 2 degrees. This is angle alpha that is equals to 45 over 2 degrees, and this is also angle alpha that is equals to 45 over 2 degrees in its size. So you can write here that this is angle SQB equals to 45 over 2 degrees in its size. Then I copied the right triangle PBQ in a new page and we analyze this right triangle PBQ. Actually, this is the right triangle PBQ that I copied from the original drawing. We have already found out that side PB equals to the square root of 2 units in its length, side BQ equals to the square root of 2 times x units in its length, and this angle PQB equals to 45 over 2 degrees. Okay, so in this right triangle PBQ, tangents 45 over 2 degrees equals to PB over BQ. Again, tangents 45 over 2 degrees equals to PB over BQ. PB is square root of 2 and BQ is square root of 2 times x. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 gets cancelled, and after cancelling square root of 2, this expression equals to 1 over x. So in total we actually found out that tangents 45 over 2 degrees equals to 1 over x. This is equation number 1. According to equation number 1, we found out that tangents 45 over 2 degrees equals to 1 over x. And we actually have the trigonometric identity that states that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. Here we defined theta is 45 over 2, so if theta is 45 over 2, it means that 2 theta is 45. Then we substitute theta in this trigonometric identity by 45 over 2, and we substitute 2 theta by 45. And found out that according to this trigonometric identity, this is actually equation number 2, tangents 2 theta, so 2 theta is 45 degrees, and it is equals to 2 times tangents theta, and theta is 45 over 2 over 1 minus tangents square theta. So it is 1 minus tangents square theta, and theta is 45 over 2. So in conclusion, according to equation number 2, we found out that tangents 45 degrees equals to 2 tangents 45 over 2 degrees over 1 minus tangents square 45 over 2 degrees. And we know that tangents 45 degrees is 1. Then we define tangents 45 degrees, tangents 45 over 2 as t. Okay, again, we define tangents 45 over 2 degrees as t. So again, tangents 45 degrees is 1, and it is equals to 2 times tangents 45 over 2 degrees, and tangents 45 degrees over 2 is t, so total this expression equals to 2t. So in the numerator we have 2t over 1 minus tangent square 45 over 2. If tangent 45 over 2 is t, then tangent square 45 over 2 is t squared. So in total, in the denominator we have 1 minus t squared. 1 minus t squared. So in total, according to equation number 2, we actually found out that 1 equals to 2t over 1 minus t squared. If we multiply this equation by 1 minus t squared, and found out that according to this equation number 2, 1 minus t squared equals to 2t. Here we added t squared to this equation number 2, and finally found out that 1 equals to t squared plus 2t. Here we subtract t from this equation number 2, and finally found out that t squared plus 2t minus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0, the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 1. And the variable that we are looking for in this quadratic equation is t, so x equals to t. Then we put the data inside this equation in order to find out the value of t, because x equals to t. So x equals to 2, so we substitute x by t, and it equals to minus b. b is 2, therefore minus b is minus 2, plus minus the square root of b squared. b is 2, so b squared is 2 squared, that is 4. Minus 4 times a is 1, times c, that is minus 1. So it is minus 4 times 1 times minus 1 over 2a. So it is over 2 times a, and a is 1, so it is 2 times 1. So in conclusion, we found out that t equals to minus 2 plus minus. Inside the root we have 4 minus 4 times minus 1 is plus 4. So in total, inside the root we have 4 plus 4, that is 8. Okay, again. Actually found out that t equals to minus 2 plus minus, inside the root we have 8 over 2. So t equals to minus 2 plus minus, 8 is 4 times 2, so we substitute 8 by 4 times 2 over 2. So t equals to minus 2 plus minus, the square root of 4 is 2, so inside the root we left only with 2. So t equals to minus 2 plus 2 times square root of 2 over 2. So t equals to minus 2 over minus 2 is minus 1, plus minus 2 over 2 is 1. So in conclusion, found that the t equals to minus 1 plus minus square root of 2. So here we will have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. And the second solution for t is that t equals to minus 1 plus square root of 2. So according to the first solution, t equals to minus 1 minus square root of 2. But according to our definition, t equals to tangent 45 over 2 degrees. But tangent 45 degrees over 2 is a positive number. So t is a positive number. And the positive number t can never be equal to minus 1 minus square root of 2, that is a negative number. A positive number can never be equal to a negative number. Therefore, we cancel this solution, and we left only with the second solution that is possible for t, that t equals to minus 1 plus square root of 2. And according to our definition, t equals to tangent 45 over 2 degrees. So t, that is tangent 45 over 2 degrees, equals to minus 1 plus square root of 2. So according to equation number 2, tangent 45 over 2 degrees equals to minus 1 plus square root of 2. This is according to equation number 2, while according to equation number 1, we have already found out that tangent 45 over 2 degrees equals to 1 over x. So we have two different expressions for tangent 45 over 2 degrees. Therefore, we created equation number 3 that states that tangent 45 degrees according to tangent 45 over 2 degrees according to equation number 1 must be equal to tangent 45 degrees over 2 according to equation number 2. So here we have so tangents 45 over 2 degrees according to equation number 1 is 1 over x, and it must be equal to tangents 45 over 2 degrees according to equation number 2, that is square root of 2 minus 1. So according to equation number 3, I actually found out that 1 over x equals to square root of 2 minus 1. Here we multiply this equation number 3 by x, and finally we found out that 1 equals to x times square root of 2 minus 1. Here we divided this equation number 3 by square root of 2 minus 1, and finally found out that x equals to 1 over square root of 2 minus 1. Then we focus on this side of the equation, and we multiply this side of the equation by square root of 2 plus 1, and then we divide it by square root of 2 plus 1. So actually we multiplied it by 1, so we change nothing. Again, we multiply this side of the equation by square root of 2 plus 1, and then we divide it by square root of 2 plus 1. So, and we found out actually that x equals to the square root of 2 plus 1 over the square root of 2 minus 1 times square root of 2 plus 1. According to the algebraic identity that a minus b times a plus b equals to a squared minus b squared, we will get that square root of 2 minus 1 times square root of 2 plus 1 equals to the square root of 2 squared, that is 2, minus 1 squared, that is 1. So in total, this expression equals to 2 minus 1, that is 1. So in conclusion, found out that x equals to the square root of 2 minus 1 over 1. That is actually square root of 2 plus 1. So in conclusion, found out that the length of line segment BC that is equals to x, it is equals to either square root of 2 plus 1 units in its length, or BC that is equal to x, it is equals to 2.414 units. Okay? Thank you very much.